speech on that particular thing. Myself, Amol Kalsekar, I am taking care of this initiative of electrical safety in the buildings pan India. I am part of different committees of BIS like ATD 9 committee, which is very specific for the developing the standards for cables and wires. I am also part of ATD 20 committee as well as CED 46 committee, where National Electrical Code and National Building Code is, we can say, worked upon, developed, reworked, so on and so forth. So myself and Saliji are part of these two committees. Apart from that, I am also part of different committees like renewables as well as the LVDC part of it. So this is my short introduction, wherein I am involved in many such technical we can say committees where I am fortunate enough to contribute myself for this particular service for the nation. So in my presentation, I'll start with some we can say bad figures. Those bad figures are basically how bad we are as far as electrical safety in India is concerned. So these are some of the data collected from the Central Electricity Authority and the we can say fire from we can say NCRB. Okay, which talks about on daily basis we can say lost the life of around 17 people we can say on, per day, and this is the recorded we can say data. So if we just imagine the kind of non-recorded data or the data which is not recorded, this number 17 numbers can be multiple times. So we are in that bad state of affair where when it comes to overall safety in the buildings, we are in this particular condition, which is very sad. Saliji also showed that bar of comparison of our country with the other countries, where we are far off than the other, we can say, from this particular slide. Another important thing is when we talk about electrical accidents, maximum accidents happens at the, we can say, LV, we can say, section, not at the we can say generation and transition part, but then the distribution side of it. And in LV, maximum accident happens, which basically we call inside the buildings. And we have a classic example of some days before near your Charminar also, that everything as far as electrical hazards comes, that comes inside the building and not outside the buildings. So why does this happen? What is the core reasons for this? These are the four reasons where exactly the entire reason of the electrical fire incidents or the fire incidents which also later cause electrical hazards in the buildings. It is not only electrical that causes the fire incidents, but fire also sometimes impacts the electrical we can say infrastructure inside the buildings. So these are the four key reasons, and wherein the we can say where architects plays a main role together with the electrical designers or the consultants is the design part of it. If you sit together with the electrical consultants and the contractors, whoever are the designers as far as electrical infrastructure is concerned, and then work with them properly that what are the key aspects as far as safety to be addressed inside the building is concerned, then it will be served not for the current requirements as well as for the future requirements. Second is something called as defective material or the substandard materials, which I'll talk a bit in detail in my upcoming slides, that how substandard material impacts the entire electrical infrastructure of the buildings. Then later workmanship, if it is not a kind of certified electrician or the electrical contractor, then also we make face a lot of challenges as far as electrical installations are concerned. Followed by, if everything is fine, but if we don't do the balance, checks and balances of those electrical installations, whether it is in line with the required load of the buildings and so on and so forth, which we discussed earlier also during the day, then also there are we can say challenges related to electrical safety. So these are the key four reasons where we are facing problems as far as electrical safety is concerned. So electrical design includes many factors, like we talked about circuit design, planning, protection, distribution, etc. But for this 10 to 15 minutes, I will talk more about the veins of the electrical system, that is wires and cables. So as rightly sir said, this is something where we are completely unaware of what to select, what to check when it is going inside the buildings. So, and most of you are also aware that because of cost pressure, we always observe the provision of bare minimum circuits inside the building. Hope you people will agree with me. Okay, what is our actual requirement and what is actually been provided by the developer or the electrical consultant inside the building, there is a huge gap. And that gap needs to be addressed at the design level which we talked about. So, as far as cables are concerned, there are various factors like current carrying capacity that varies according to the ambient temperature and the atmosphere, then the derating of the cables. These are the terminologies I am not expecting you to, we can say, learn or the by heart or apply. This is the job of the electrical designer or the consultant who designs the electrical aspects. But then we need to ensure that whether those aspects are in place, that we need to check from the electrical consultants. For example, whether they have selected the right sizing of the cables when it comes to the required load in the building. At least that we can check with them, whether have you provided the right sizing. Then the class of the conductor. Class of the conductor, I'll talk in details in my upcoming slides, because when we talk about copper conductor inside the cables and wires, there are two types of conductors which are used, that is class 2 conductor and class 5 conductor. And a classic example of that in recent data centers mishap, I will share that with some example in my upcoming slides. Then we are also talking about cross section, conductors cross section, matlab the size of the conductor inside the wires and cables, that is whether it is in right proportion or not as far as your current carrying capacity is concerned, your considering the load, as well as when there is some fault occurs in that conductor or the wire or the cable, whether your circuit breaker is tripping in right time or not. So it is all linked with the sizing of proper conductor is concerned. So it is nobody who decides by himself that what is the size of the conductor to be used for that particular application or for the particular, we can say, circuit inside the house or in the building for sizing the wires and cables are concerned. It is very well defined in our National Electrical Code and National Building Code of India that what are the sizes of wires and cables to be used for the particular load. So answer to your question, sir, if we refer our standards, okay, you don't have to by heart those, we can say, sizes or the numbers or the quality of that. It is clearly mentioned in our standard, that is National Electrical Code of India, National Building Code of India, that for every load there is a specific size of wires and cables. Only we need to ensure with the electrical contractor or the consultant who designs the electrical infrastructure inside your building that whether they have followed the sizes or not. Very important thing, if you see, there is one statement predominantly mentioned in our National Electrical Code of India as well as National Building Code of India, that aluminum conductor in size less than 16 square mm causes termination problem leading to heating and enhances the possibility of fire. Enhances the possibility of fire. So let me clear that one more time, that what all fires you see because of electrical short circuit, in many cases, this is one of the key reasons that we are not using the we are not using the copper conductor of this size prescribed in our standards, codes and regulations. Okay.
Can you not ban that? Can you not ban that?
That again depends on the checks and balances, sir. If the, as Sali sir has shown you the last slides, if somebody found guilty as per as Electricity Act, okay, they can be behind the bars. But still in our country, we are not scared of all these legal aspects as far as we can be behind the bars or we can be fined or so on and so forth, because the testing and verification parameters in our countries are very poor. Okay. Yesterday I was also talking with a couple of architects from your group only. They were saying that, sir, when building gets completed, from other aspects, we are quite well versed with what to check and what not to check before handing over the building. But in case of electricals, we are not sure what exactly needs to be checked. So these are some of the things if you can say as a basics of electrical infrastructure. If we check those things, I think we are in better position to say that this particular building is safe or not. Again, if you see the second statement which says that use of circuit integrity cable for all emergency applications like emergency lights, lifts, firefighting system, etc. I'll park this particular point for some time now because I have a special slide to talk about this particular technology called circuit integrity cables. Then it is also said that it is advisable to replace the wiring which is more than 30 years old. So old buildings, the latest example what we got of fire, okay, in that case this particular statement becomes applicable. If the infrastructure is pretty old, then we need to ensure minimum, okay, 30 years to change the internal wires and cables of the building. And last one is periodic inspection. So it is advised to do it every 1 year, but as per regulation it says that it should get inspected at least once in 5 years, all the buildings. Okay, and all high risk buildings like hospitals, like high rise buildings, like your public buildings, it should get inspected every year, not every 5 years. So this is something furthermore enhancement we can say, or the advancement above and over and above national standards and codes. That is the latest we can say update of CPWD specification, which is also adopted by Telangana State Public Works Department, R&B Department, which says that in all government building you should use only copper conductor. You are not allowed to use aluminum conductor inside your any government buildings from safety perspective. And you must have heard, not heard any incidents in recent days in government buildings that this kind of incident happened. That is because of the efforts by Mr. Linga Reddy, who has ensured that all the buildings in government buildings in Telangana should have only copper conductor, and aluminum conductors are not allowed on those buildings. So this is just another reference point apart from National Building Code and Electrical Code of India. These are again some reference point which I won't go in detail, but I'll just read a couple of them, which says that CA regulation says 2023 says that refer Indian standards and mention to follow them in accordance, hence it becomes mandatory. Then if any of you are understanding a bit of the conductivity or the we can say current carrying capacity of the conductor, it is very specifically mentioned in our standards that current carrying capacity as claimed by manufacturer, I am again repeating, current carrying capacity as claimed by manufacturer under normal condition may reduce to 50% depending on situation and the method of the installations. So the capacity suggested and decided by the cable makers, okay, when it comes to the actual implementation part of it, we need to ensure that the sizes should be on higher side, okay, so that we can match the required current carrying capacity with the size which has been taken from the cable maker. Okay, so I think there are around 4 to 5 cable makers available in our group today, who are our partners like RR Cable, Finolex, KEI, V-Guard, Anchor. These are our partners who support us to conduct such kind of programs pan-India through their social initiatives. So they are more concerned about safety, and they are more interested in we can say sharing this message of safety along with us. So they are connected with us with more than 10-15 years now. So any information, technical information, if you are interested, you can always get in touch with those experts sitting over there. They will guide you more on how to select, what to select, and when to select. Okay, as far as cables are concerned. One such image was shown by Sali sir also, which says that how aluminum conductor inside the building, I am not talking about underground cables. I am talking about the cables, any wires and cables used inside the building, from your panel to meter room to individual floors, and from individual floors to individual house or the office or any premises we are talking about. There, if you are using aluminum conductor, there are certain side effects of that. There is a very particular property, a peculiar property of aluminum conductor, that it contracts and loosens. Okay, during the extreme, we can say current carrying condition, when the lights are on, okay, when it carries the current, okay, it expands, okay, and when it is cold, it again comes to the same place. So what happens because of that? The termination, the connection gets loosened up, and if you don't check that every month or every 2 months or every 6 months, it will immediate impact, okay, on heating up the insulation and some or other day a big or small fire coming out of that. So there are a lot of disadvantages of using aluminum conductor inside the building. So it is a kind of a slow poison which we are using inside our building. So it is a humble request for you to please do check with your electrical consultants with whom you are working with, and ensure that all small sizes cables as well as in critical buildings or the we can say high risk buildings, all conductors should be only of copper conductor and no aluminum should not be allowed in that. Now I will come to very specific question again asked by this Balu sir some time back, that there are a lot of confusion created in the market as far as cable technologies are concerned. FR cable, FRLS cable, FRLSH cable, zero halogen cable, HFFR cable, FS cable. What is the sanctity of this particular, what is the, we can say, use of these different technologies? Is it just for the purpose of creating some curiosity among the users that yes, this kind of technology I am using or something of that sort? It is completely wrong. Every technology has got certain purpose. Every technology has got certain applications to be used as far as building electrical infrastructure is concerned. So for example, flame retardant cables are only designed to prevent the spread of fire in new areas. So if you are where you are working in that particular building electrical infrastructure, if they are using FR conductor for the cables, FR cables, then it means that that cables are used for the purpose of not spreading the fire. But that particular cable will release the smoke. If you must have heard that people are dying not because of the fire but because of smoke, toxic smoke which are coming out of the PVCs. And this is one of the examples. This is the cheapest option available in the market, FR, which don't spread the fire but it creates the smoke. So try and avoid that. Second one is FRLS or FRLSH. Flame retardant, low smoke coil and halogen. Low smoke and halogen rather release the toxic smoke from your cables. Okay, so again, when it comes to the safety of our house, safety of our, we can say, offices or other commercial premises, it is always preferable to go for HFFR cable, okay, from safety perspective. And the fourth and last but not least, most important is fire survival cable, FS cable. If you remember in earlier slide, I talked about circuit integrity cable, which was mentioned in our National Electrical Code and Building Code of India. The purpose of this particular cable is, it has got the circuit integrity of 180 minutes. It is very important from your architect's perspective, where you play a role in fire safety as well. This cable circuit integrity is 180 minutes. That means in extreme fire condition, these cables will remain active for 3 hours. And this is specifically used for all emergency circuits in your buildings. Emergency lights, emergency lifts, your entire fire system, okay, works on this particular cable. Many times you must have heard about the building has got good fire system, but it didn't work during the fire case or fire condition. Why was that so? Because that cable was not capable of handling that system. Okay, so we are also working with different state fire authorities to mandate this particular cable in all high-risk buildings. Okay, and that is in progress in most of the states now. So this particular cable plays a very relevant role as far as fire safety in the buildings is concerned, because this particular 3 hours are quite sufficient enough to evacuate the building during extreme fire condition. Now we will talk about something which is very relevant in current scenario when we are talking about emerging trends and technologies are concerned. You must have heard about, or you must be involved a lot in, we can say, designing for the data centers. Then now it is a mandate in most of the states to have EV charging infrastructures inside the buildings. It is also the mandates in most of the states to have solar PV installations, rooftop solar PV installations. I think in your state also all these three are mostly prevalent. But if you see the irony in current scenario, in recent condition we have heard from some of the developers and the consultants of data centers. They said that to reduce the cost of the we can say data centers, total construction of data centers. I'm sorry to use this word, but these designers or the developers or the owners, they are trying to play with the life as well as the, we can say, efficiency of data which we are going to work as far as the data center is concerned. They are directly playing with the efficiency of that particular front. Reason I'll tell you. There is no standard mentioned in our country or rather globally to use class 5 conductor. I'm now coming to the conductor part of it, how dangerous those words are. Okay, so that you can always check with your electrical, we can say consultants or the designers, that please do not use these particular specifications in your electrical specifications. Okay, class 5 conductor aluminum cables are specifically asked by the designers or the developers, and those specifications are given to the cable makers to develop or rather to manufacture those kind of cables to reduce the cost of the total, we can say, infrastructure of the data center. Can you imagine if you are spending thousands of crores on that data centers, okay, and ultimately if you are using this kind of cheaper option as far as cables are concerned, which is the life of the entire data center, what kind of losses you can imagine in coming future? So this is the kind of examples which happens only in India. Nowhere people compare the cost with the quality. Only in India we compromise quality over cost, rather cost over quality. Same thing happens in the solar installations also. We have a very, we can say, mandatory standard, that is IS 17293 for solar DC cables. Okay, but if you see the specification of most of the state development, renewable development authority, they have still not adopted this particular standard. Again, the cost is the pressure. Okay, but we need to ensure that this standard is mandatory through Government of India. And if we don't use that, that developer or the consultant who are specifying this particular non-standard, we can say, material, can go in a deep trouble. Apart from that, AC cables, DC cables के ठीक है अलग से standard है. AC cable के लिए भी there is very specifically mentioned in the National Electrical Code of India that below 25 square mm you should not use aluminum conductor in the solar installations. But if you go and check in nearby areas, you will not find this is followed. Why? Negligence, and other one is to save the cost. So I hope I answered your question, sir, that where these are all basic things. Even if we share this presentation with you in a PDF copy, and if you ask them to follow this particular thing, I think you have your purpose is solved at that particular point of time. So this is all about wires and cables are concerned. Now it comes to the work and workmanship are concerned. So workplace safety, understanding scope of work, all these are quite relevant and we can say directly on daily basis. This comes to your practice. So I won't stress more on these particular pointers like coordinating with other agencies, checks and follow drawing outlets, layouts, then precautions in respect to hidden works, and then segregation of circuits and systems. This is already explained by Sali sir, statutory obligations, so I won't get more into that. But there are provisions where the defaulters can be behind the bar, but we are still playing with the life of people and the life of properties after even charging on higher side from the users. One more important, my last slide, then I'll sum up my presentation. Last slide, I want to provoke one thought in your mind. Many a times when we talk about using only copper conductor inside the building, there is always a question raised by the developer or the builder or the consultants that cost of using only aluminum conductor inside the building goes on higher side, 2 to 3 times than what we are using in aluminum conductor. We did a survey of more than 15 buildings pan India, okay, and the outcome is when we consider the ratio of cost, I'm talking about the construction cost of a building, not the selling cost. Construction cost of a building vis-a-vis the wires and cables cost used inside the buildings. You won't believe and imagine the cost in residential building for wires and cables is coming around 1.1% of building construction cost. I am again repeating, not the selling cost but building construction cost, and wires and cables cost is coming to 1.1% if you follow proper standards. Okay, and in commercial building it is coming to somewhere around 1.6% average. Okay, and if you use only copper conductor, it will further increase by 0.5%. So 1.5% to maximum 2% if you spend in your building for proper electrical installation, wirings and cables, you are safeguarding your construction, okay, say next 15 to 20 years, by saying that my building, the layout from architectural perspective, the design which I have developed for this particular building, this building is safe for next 15 to 20 years from electrical perspective. So that will add, we can say, value to your reputation, to architect's reputation, to the developer's reputation, and can that become a kind of one of the USPs for your construction or the company's name? So with this thought, I would like to sum up my presentation. Thank you very much.